Find the equation of the tangent line to the hyperbola xy equals 1 at the point -2 and -1/2 using the slope of the tangent line mt equals the limit as h goes to 0 of f of a plus h minus f of a over h. So the equation of the hyperbola can be written as, we can rewrite this, rearrange the terms here, and we can write this as y equals 1 over x. And now we are going to be using the following expression here, where we're going to replace the a with our value of x, which is, that's going to be our a, -2. So what we have here is that the slope of the tangent line equals the limit as h tends to 0 of f of -2 plus h minus f of -2 over h. So now what we're going to do is we're going to substitute in the following function, the hyperbola. So we're going to get, in the numerator, we're going to get 1 over -2 plus h minus 1 over -2, and that's going to be over h. We have 2 minus signs here, so that's going to become positive. So this can be written as the limit as h goes to 0 of 1 over -2 plus h plus 1 over 2 over h. Now we want to put, in the numerator, we want to put the two quotients on a common division line. So we need the lowest common denominator. So here our lowest common denominator is going to be 2 times -2 plus h. So if we apply that, we can rewrite this as, so up here in the numerator, above the common division line, we're going to get 2 plus -2 plus h, and the denominator, we have the common denominator, like that, over h. Now if we take a look at the numerator here, we see that if we drop the brackets, the 2 will disappear. Okay, so what we have left here now in the numerator is just an h over this lowest common denominator over h. So we're going to get rid of this division here. So this is h over 1, h over 1. So we're just going to convert this so that we get a multiplication instead. So we have the limit as h goes to 0. So we have h over 2 times -2 plus h times 1 over h. And now we can see that this h cancels this h. So what we have left here now, I'm going to continue up here. We're left with the limit as h goes to 0. In the numerator we just have a 1. In the denominator we have a 2 times -2 plus h. So at this point we can substitute in the h, the 0 for the h. So if we do that, we're going to get 1 over 2 times -2. and this is equal to 1 over 4, negative 1 over 4. Okay, so this here, that's the slope of the tangent. So we refer to that as m sub t. So now that we have the slope of the tangent and we have the x and the y coordinates of a point, we can write the equation of the tangent line using the slope point form. So y minus y1 equals the slope of the tangent line times x minus x1. So y minus the y coordinate is negative half, so it becomes plus a half, equals the slope is negative 1/4. X minus the x coordinate is negative 2, so it becomes plus 2. Okay, so this is the slope of the tangent line in slope point form. The question doesn't specify whether we should write this in the slope point form, slope y-intercept form, or general form. So for this purpose, this is fully sufficient.